Before we get started with the log topic here, I want to first look at your Winbox for a second. Up here in the top we have a dashboard. If we drop that down, it allows us to add features to the top of our header. So we can add the time. You notice now we have the system, the router system time right here. We can add the date. We can add CPU usage. We can add memory. We can add the amount of uptime. These are all important things when you're doing scripts and things like that. Once you put them over here, you can simply drag and drop to reposition them, whatever sequence you want. So it's not that difficult at all. So that's how we get these time parameters and router parameters up here on the header of the Winbox. Something else on the Winbox, if you notice it says who's logged in, that's me. It says what we're logged into. In this case, it's a MAC address. So Winbox is doing it the version of the Winbox, and then they're logged into an RB951G modem. That's the rest of the model number. And it even tells you what software it runs on, MIPSBE. So there's quite a bit of information right here on this one single line. So now let's get on with our log files. This log file always displays any reported errors after the system was rebooted. So our uptime's been 1 hour and 5 minutes. So in 1 hour and 5 minutes it generated these log entries. Some of them aren't errors, some of them are just notifications. So if you notice the router rebooted, then DHC server connection error. It had a problem connecting to that server. And it talked about pre-shared keys not enabled. We also disabled WPS. So let's look at that for a second. Pre-shared key is not enabled. So we come up here to quick set. And sure enough, there's no password here. There's no password for our Wi-Fi. So it caught that mistake. Hardware offloading activated on the bridge ports. So what is a bridge and what are the ports? So let's just say that the bridge is something that funnels all the traffic through it. Hardware offloading simply means that instead of the CPU having to process all that data as to where this packet goes, the hardware processes it with a special chip. Spatial chip knows how to route things that it already knows about. So that takes big load off the CPU. Notice our CPU right now is only running 2%. Ethernet 1 link up speed is 1 gigabyte full duplex. That's because I have a 951G router. 951 and 941 can only do 100 megahertz. But this router is a little bit more capable. And it shows you connection speed. Remember, link 1 is going back towards my internet modem. Ether 2 is where my computer's plugged in. And it also connected at 1 gig. And it tells you the user admin logged in at this MAC address and this time. And it shows items were changed in the system info. It doesn't tell you what the item is. It says items were changed. And it goes on down the list. All the way down here there was a DNS error on this time and date. And DH server connection, that worked on that time and date. So our DH server is in fact working. We can prove that. Come down here and we'll go to bookmarks. And you can see it is working. So that's correct. It didn't work when it first booted. That's probably because it hadn't established connection with the telco router at this time. Telco router and the telco modem. But now everything's working fine. So where does this log go? Well, we have choices here. If we go to System, we go to, so you log in, here it is. Go to login. First of all, we can define what items are considered log valuable. And then where do you send the information? So disk is to, if you have a thumb drive, this 951G does have a thumb drive. So you can send it to the thumb drive. Echo it means echo it to the console. The lower priced computers don't have a serial port for a console, so that's not a good choice. And then memory is where it stores it in memory on the router. or remote, you can send it someplace else. Now the action, if you say disk, it's going to send it to that file name. It'll be this many lines, 1,000 lines per file. The file count is 2, and we can stop on full if we want. So I'm just showing you this information. If it's memory, then it's 1,000 lines. And once that 1,000 lines has been saved in memory, then it creates a log file over here. It'll create a log file with the number 1. Then when you get another 1,000 lines in memory, it'll create a second log file, log 2, etc. So that's how it keeps track of old logs. The only way to query these logs is to reboot the router. And then you can delete any files that show up in here that are old logs you don't want anymore. So that's pretty much a high-level overview of the logs. That's all we need at this time. Let's do a little bit more with the terminal command at this point. Let's just say system and do question mark, and notice it shows other options here. Let's go to clock. We haven't been there lately. So CLOCK, clock, and now we do a question mark. What can we do with this clock? Apparently we can print the values. So let's try that. What can we print? Question mark. And it tells you we print the interval and whatever that stuff means. I don't know what it means. So we'll just print the clock itself. You notice we have the time zones, all that. We can change all these things. So how do we change them? Well, we look at the question mark. We can edit, export, get, or we can set values. So this is how you use the terminal. Help. It's the question mark is a help, even if you're doing something that you think doesn't need help, like print. Sure enough, there is help. We can print a file. We can print an interval. We can print it as value. We can print without paging. That means display all the information continuously. Apparently, this terminal does one page at a time if you exceed a page. So there's various things we can do with this system. Let's close it. Let's open it up again. What about quick setup here? If we do a question mark, you notice there is no quick set. There's a quit. There's no quick set. And the reason is the quick set isn't a function in the router. Instead, it's a collection of functions. It's a collection of wireless information, your WAN information, your local network information, your DHCP server, your wireless passwords, and things like that. So it's not really a system function. It's a collection. A system function is one place to make your life easier. So as long as you know where you want to go, let's go to IP DNS again. And you notice we have no dynamic servers, we have no servers. All we have is this DOH servers. And if we go to static, we can see what those are. Notice we still have our router server, but we told it not to use any servers. If you remember when we configured this, we said don't use any servers. The server's names was blank. So it only uses the DOH servers in this case. Okay, your DNS cache is another temporary record that the router keeps for you. If you notice here, we have all the DNS entries that were performed since this booter was routed. And, or I should say since the last flush of cache. And you notice there's quite a few entries here. This computer went quite a few places. So I'm going to flush the cache. That will delete everything except the basic information it needs to do DNS searches. So that's what's left. So if I'll go ahead and start up my browser and then just shut it down, look how many more connections that established. So these are DNS connections. And it doesn't hurt to voice it once in a while. It gets to be a pretty long list. Next, we're going to talk about the watchdog timer. So what is this watchdog timer thing? Well, we come up here and look at it. Basically, it provides two functions. Software watchdog timer, mostly caused by hardware malfunction. Device can recover itself with a reboot. And the ping watchdog can monitor connectivity to a specific IP and trigger a reboot if it loses that. So this allows you to make sure your router does reboots to try to remain online when the issues are taking place. So you notice we have a log here from our router on a fresh start. It's only got 7 entries. So we're going to go ahead and go to System, go down here to Watchdog, and we're going to put in a watch address. 192.168.88.23. It has to be a valid address. The router has to know it can get to it, it won't even try. So you put in a valid address, let's say 1 minute after boot. That means 1 minute intervals. Then the ping delays will be 30 seconds apart. So if it can't ping, then it'll wait 30 seconds before it reboots. If it can't check itself with its own watchdog timer, it'll wait 1 minute before it reboots. So right now we're going to force it to do a ping watchdog timer reboot by applying this information. So now we're logged back in, and notice our new log, because we did a reboot, we start with a new log, and you notice it said system rebooted because of ping watchdog timeout. Then the system rebooted and it couldn't find a DOH server immediately. And then it talks about no key for your WIN, WLAN 1, and all the usual stuff. So now we have a system that's reliable. If some hiccup happens, some little glitch happens, it'll reboot. If it finds a hardware issue, it'll reboot trying to fix it. Such as, let's say, you lose the Ether 1 connection to your modem. It's going to see that and consider it a hardware problem. It's going to reboot in case somehow it got locked up over that. If you have something that you want to keep running, such as some kind of server on your network, then you have to put in an address and keep checking to make sure that thing is running. Notice it rebooted again because I left it enabled. Every minute it's going to go out there and look and see if there's something going on, or if it finds a ping problem, it's going to fail for no ping retries. No pings were successful. So here we're going through it all again. Let me go in here and fix that before it does it again. So we go to System, Watchdog Timer, clear out the watch address to 0, apply that and say, okay, now to stop timing out on us. Another feature you need to consider with this router has to do with identity. So let's go to System, right here, Identity. And that's, if someone's trying to hack your system, they want to know what kind of router you're using. So it's foolish to leave Mikrotik router here under the identity. I always change mine to something else. Let's see. So we'll change this to Linksys. I think they do a capital there. Apply that and say okay. So now they think it's a Linksys router, which is total different operating system. It makes it harder for them to break in. Another thing that makes them harder to break in has to do with this system, users. It's users, that's why. We talked about adding an address in here so that only that address can access your configuration page. Well, as it turns out, people have learned how to spoof addresses. They can change their packets so that the source address isn't really their source address. So they can log onto your system through your Wi-Fi. Then they can spoof a different source address. They have to keep guessing until they find this address, and they can log into your Wi-Fi and do damage. Of course, to do that, they first have to know the username, they have to know the password, and then they got to figure out what address you're on. So it does cause a serious delay, but it's not absolute. So let's look at another way to make it more absolute. By the way, I would leave that disabled. It just adds more confusion. We go over here and look at our firewall rules. IP firewall. Down here, drop not destinated. So general, we're going to, the chain is to forward from the WAN to something else. In other words, it comes into the WAN, comes into the router, and it's new, and it's, you can actually say it's not destinated. That means it doesn't know where it's trying to go inside your network. So then we say nothing there, and we say drop it. So if someone's trying to get to your router configuration page, it doesn't matter what address they spoof on you, it's still not going to get there. And this is a much more secure way to prevent access of your router configuration. Another point of interest here, since we're collecting loose ends, notice we have a choice to reject it. If you reject it, it knows that it's in the right network and they can keep hacking. If you just drop the package, they don't know if they hit a firewall or if they have the wrong configuration information, they just don't know. So this helps confuse the hackers by saying to drop anybody that's coming from a WAN with a new connection. That's much more secure than putting a IP address on the username. So this is another touch on the firewall. There'll be many more touches before this subject is over.